So this is not a slide that you have, but I need to talk about eclipses. And is an eclipse of the sun where the sun goes away, and there's an eclipse of the moon where the moon appears to go away. It doesn't go away, but it just appears to go away. And so I thought I would go ahead and just draw you kind of simply what's going on with these two types of eclipses. This actually is a solar eclipse, or potential solar eclipse, and I'll kind of try to explain that to you as we go. So a solar eclipse is one where, notice that we have the Earth orbiting the sun, and we have the moon orbiting the Earth, okay? In this phase, we talked about phases of the moon, and can you see where actually this is what we call a new moon? A new moon phase, okay? In that the illuminated part is over here, and the part that we see is dark. But can you see where if these three lie, what we say, in a plane, if they're lined up just right, what will happen is that as the moon, how do we say this? As the moon moves about the Earth, okay, what will happen is that the moon will move and cover the disk of the sun that we see. Okay, so that is a solar eclipse. So as the moon, it has to be just right, and it will always be in this new moon phase. The other type of eclipse, that's a solar eclipse where the sun goes away because the moon blocks out the light. That's the way I think of it. Let's see if I can move this out of the way, move this up. Oh. My other one I've prepared for you is down here. So let's look at, we talked about phases. Notice the moon now is over here. And this actually is a phase of the moon we would call a full moon. Okay. So this sort of eclipse is called a lunar eclipse, and it can only happen potentially when the moon is in its full phase. So what happens here is, and I have some figures to kind of show you this, but what happens here is the Earth gets in the way of light from the sun, is how I think of it. So the sun is beaming light in all directions, including the moon, and usually the Earth isn't in the way, so we see a whole, that's why we see a full moon, okay, where this is illuminated, not dark, it's illuminated, our full moon. But if it's lined up just right, what happens is that the Earth, we say, casts a shadow. It would always cast a shadow into outer space. Okay, but this shadow that the Earth's casting, the moon passes directly into that. So again, it's kind of like with a solar eclipse. For a lunar eclipse to happen, all the sun, the Earth, and the moon have to be lying in what we say the same plane, lined up just perfect, when the moon is in its full phase. Okay. You should have this slide. So a lunar eclipse was when we can no longer see the moon. And that happens when the moon only potentially is in its full phase. And what's happening there is that basically the moon is passing into the Earth's shadow. A solar eclipse can only potentially happen during when the sun is in its new phase. Okay, and in that case, the Earth passes into the moon's shadow. Okay, I don't know, I hope that makes sense. Yeah, I think I already said these two things. A lunar eclipse can only happen during a full moon. A solar eclipse can only happen during a new moon. Now, the reason they don't happen, that we don't have eclipses more often, is because actually what you're looking at are kind of, is as the Earth, you're looking at the Earth orbiting the sun, and then here we show the moon orbiting the Earth. And actually the plane that the moon, as the moon orbits the Earth, is tilted 5 degrees, okay, outside of what we call the plane of the ecliptic. So it's a little bit hit and miss for the moon to be lying in the plane of the ecliptic, which is the plane that holds the Earth and the sun, at its new phase or at its full phase. So a new moon can give us what? Solar eclipses, and a full moon can give us lunar eclipses, but it has to be just right. So here's some pictures got for you. This is showing you the shadow that Earth casts into outer space. Actually, both shadows, but this one's, no, just the shadow of the Earth casting in outer space. And it looks kind of like a bullseye. So if we look over here, can you see where we have the nice deep shadow? Actually, that's called the umbra part of the shadow. Okay, and then we have the lighter part of the shadow. That's called the penumbra part of the shadow. So for lunar eclipses, when the moon just goes through just kind of this light part of the shadow, okay, that actually is called a penumbral eclipse, okay, but when it goes through the umbral part, that is called a total eclipse. I think I got that right. Okay. Now the other thing about it, does this make sense to you, that eclipses will only be viewed by a certain part of the world? Okay, a certain part of the world is only privy to when this is occurring. So types of lunar eclipses look like this. We have the total lunar eclipse up here, where the moon is passing through the Earth's umbral part of the shadow. We have a partial eclipse. Those are pretty cool too. Total eclipses are outstanding. That's where you get your blood red moon. Okay. A partial eclipse is where you have a bite taken out of the moon, kind of like you see here. It will never go totally black, dark, but the bite's pretty cool. Now, one of the things about kind of being shown here, let me see if I can zoom in. I've seen a few eclipses. I love eclipses. I introduced the term terminator. Okay. Now, that might look like a terminator, but it actually looks nothing like a terminator through the telescope. It's going to be my point. The third type of lunar eclipse is called a penumbral lunar eclipse. And I'm just going to put maybe a sad face here, because I would not worry about getting up in the middle of the night to watch a penumbral lunar eclipse. You can barely know they're happening because the moon is passing through kind of that light part of the Earth's shadow. Solar eclipses. So solar eclipses can only potentially happen if things work out, but the moon has to be in its new phase, a new moon. And here you see, again, like the Earth casting a shadow has a dark part, umbral part of the shadow, okay, and then a penumbral part of the shadow. Okay. So different types of lunar eclipses look like this, where we can have the total solar eclipse, that's the whole enchilada. Those are kind of rare, and in 2 years, excuse me, less than 2 years from right now, August 2017, you don't have to go too far in North America, maybe the St. Louis area is where we're going to go, I think, to see a total solar eclipse. A partial solar eclipse is where you just get to see the bite taken out of it. Now this, you would not see this unless you had like welder's glasses or something. You have to protect your eyes. This actually, during a partial solar eclipse, you won't even hardly know what's going on. Okay, you might see some kind of cool shadows cast, but otherwise, no. Then there's another type of eclipse, and again, you can't see it naked eye, I don't think. It's called an annular eclipse. And in this case, basically it would have been a total eclipse, but the moon is a little bit too far to kind of cover the entire disk of the sun. An annular eclipse. So eclipses, where are they? Well, I have a table coming up, but see, this is like showing you a solar eclipse where the bite is taken out of the sun and then the sun is revealed again. Is that not cool or what? And I said that you can only see solar eclipses, you're privy to them in certain parts of the world. These are kind of where your solar eclipses are through 2038. Okay. But lunar eclipses, we've got one coming up. Let's see if we can find that little rascal. Okay, actually here in North America, September, I think it might have been 27th, 28th, but that was like that 9 p.m., I'm pretty sure, is when that total lunar eclipse happens. Now, if you're like me, what you want to do is, if you're interested in catching a celestial event like this, you need to look at the internet, look at several sources so you don't get the wrong time. So